Right, the next job is to prepare the motor. So, remove the insulation here. We don't need a lot. That's probably only about 2.5mm. These wires will take away quite a bit of the soldering heat. This size tip I've got is pretty good. I know from experience that it will do these okay. Now I want to get a good solder here because I want the solder to flow freely into all the tiny wire strands. And the best thing about it is this is silicone covered wire, so it won't melt like PVC stuff does. ESCs, and keep them nice in parallel. To melt on there first. Right, first one's not as quite perfect, so I'm going to clean my tip on a wet sponge just off camera. Re-tip. Yes, looks good. Now I can see here I've got just a little tiny spike. I don't know if you can see it, but with some thin cutters I can just snip it off. And actually on this negative connection here there's a little bit of a spike, so I'll just snip it off. If you're covering something with heat shrink, you don't want any sharp edges because it has a tendency to pull over it. Right, now the reason I took the arm out of the frame was because I need to put some heat shrink over the arm. Now I'm going to sit this on here. This needs to be insulated, and I also want a bit of physical insulation there, so as the heat shrink shrinks down, it's not going to squash anything against the hard edge. What I'm trying to say is I just want an insulation layer. Back with my favourite stuff, 3M's VHB, very high bond it stands for. You can get this in all sorts of shapes and sizes. This particular reel is grey colour, but you can see how it's quite thick, and that's what I want. Position to be dictated by the length of the motor wires without any undue stress on them. So my 2mm hex key, 3 12mm screws, screw lengths and motors are important. The screws that come with the motor you can't guarantee are the ones to use, because whoever packed them in the box somewhere in Japan or China didn't know what thickness arm you'd be using. So what you've got to do is add the thickness of your arm. Bear with me a sec. add the thickness of a mount here, and probably add about 1mm or so on, and that's the longest you want. You do not want screws that are going to protrude out of here so far that they touch, crush, damage, whatever, short circuit, whatever word you want to use, either the windings or where the wires come in and join them. These particular ones are 8mm. I've ordered some 10mm because they aren't quite long enough. 10mm on this will be. I'm going to take the backing paper off, and without putting any stress on the motor wires at all, I'm going to stick that down parallel on the arm. And there we go, it's in place. Bit fiddly, but it's worth it. I've got my 2 power wires, my ESC control wires, the motor all nicely covered. Heat gun ready. Get rid of what we don't need. Do I use that again? Yes, the piece I cut down is the right width for another one, so I can use that on number 2. I'm applying gentle heat as evenly as I can, rotating the arm, getting the heat shrink to shrink in the middle, and then when it's fairly tight, I'll then go to the ends and get the ends finished down. Let's bring the quad frame back in. It is. Notice something here. The screw that I put in for this pillar is stopping the arm going in, so I'll just have to remove the screw. There we go. Have to remember to put that back in. So now I can go back in, get the arm in place. Got me 12mm screws. And so I don't forget, I'm going to put this little one back in straight away for the mounting. Now we connect to the flight controller. 2 power pads. This is marked B+, this is marked G. So these actually are going to cross over, but never mind. So let me do the G, which is ground, which in our case is negative, which is black. Let me cut that to about there. I'm trying to get a nice curve on it, but I don't want to have it too much loose, if you know what I mean. And then this one I'll do the sort of same with. I'm going to Stop it there. Remember when you're doing this, if in doubt, cut a little bit longer. It's very easy to shorten the wire. It's a bit more difficult to magically make it longer. So those pads are fairly small, and there's no need to strip loads of insulation off these wires. You've got a good soldering joint. The current carrying capacity is well enough. So, solder. By the way, I'm just using ordinary 660/40 flux cord. I won't tin the wire over the flight controller, because if I have a blob of solder drop onto the board, it might break something I don't want it to, which can be a sight to get off, and if I didn't happen to notice it, I'd certainly know about it when I powered the board up. So, right, let me have a good check. Nice good soldering joints, and there's no solder splashes, no stray wires, anything like that. So that's the power, we're almost done. Now we've got the signal to do. Now on this board we have a pad marked M with a number, which is the motor signal, and then the one next to it is marked R7, which is the RX connection on UART7 on the controller, which it uses for current measurement of the ESC. I'm not going to use current measurement on the ESC because I've already got current being measured on the board as a whole, and I'm not really, it's a freestyle, I'm not really bothered about what each individual motor is pulling current wise. Overall current draw, which will give me my battery usage capacity, i.e. how far left I can fly, is the important thing. So I'm going to cut the white and black here, but just before I do anything else, I'm going to go to my soldering iron. I'm going to take off the tip I have been using, and I'm going to put on, if you can see that, a smaller one. Incidentally, the iron I'm using is an OKI, that's OKI, Metcal iron. It's very good, I've used it for years. Can highly recommend it, but it's not cheap. Right, a little bit of the strip on the white one. I'm going to use a thinner solder now. Now I'm working with smaller wires and smaller pads. Has this heated yet? Yes. This pad has got a hole in it, so when I pretend it, I might try and get the wire to go into the hole, but you'll see how this project progresses. Quite often we don't use the hole, we just put the signal wires soldered to the top of the pads. Right, I think that's gone in. It's nice and tight. I'll check into the magnifying glass later. The black wire, the ground, the common for the signal, it's twisted with a white wire to help to avoid signal interference getting into this white wire. Now this ESC doesn't have a separate pad for it, so I can tag it to this one here. So I need to shorten it a little bit. because it's a little bit closer. Now from a vibration point of view, these are very thin and I don't want them getting damaged. So, good old-fashioned lacing tape. Some people might just put a thin cable tie here, and no reason why you can't. But when I've got something that's fairly thin, cable tie buckles can be a bit large. So I'll show my age and use a lacing cord with a relief knot on the top. I don't have it with me. I want a bit of nail varnish or a little bit of varnish. I've got some APL, no sorry, FSC, flexible silicone coating, and all I want to do is just put a little blob on the knot. That will stop it loosening, and it's there for life. Recap: motor screwed in place. Make sure you choose the correct length of screw. You just want the thread to be just coming out of the mount, but you don't want the end of it to be anywhere near the windings. Comes into the ESC, nice, shiny, good solder joints. However you do it, I swapped the red and the black wires to the bottom pads on the ESC, and I put the capacitor on the top. Electrically, they're the same. Those are through plated pads, so it doesn't really matter. Capacitor, 35 volts, being double what a 4S battery will be, at least double I should say, and the negative marks on the side of running down the side of the capacitor are the negative connections which goes to where the black wire is. We mounted it on quite thick cushionable double-sided pad onto the arm, and then we put heat shrink over the whole lot, both to hold it in place but also to insulate all the joints.